You are standing in the middle of nothing, no roads, no towns, just wine that has not stopped blowing for 10,000 years. And in front of you, rising out of the dust, is a machine so large that one of its smallest parts weighs 32 tons. Its arm reaches higher than a 60-story building. It traveled over 2,000 kilometers across China to get here. And what it is about to lift, no machine on Earth has ever lifted before. You are looking at the largest crane ever built on wheels, and the reason it exists will change how you think about the future of power itself. Stop and think about your life for a moment. The lights in your room, the phone charging next to your bed, the screen you are looking at right now. Every flicker of electricity you take for granted comes from somewhere. And right now, a quiet war is being fought in the most empty corners of the planet to decide where that somewhere will be. Coal mines, oil fields, or wind. Pure free, endless wind. Whoever wins that war controls the next 100 years. And China just rolled out the weapon. It is called the Zoomlion ZAT 40000H, built in Changsha, in Hunan province by a company most people have never heard of. When engineers first wheeled it out of the factory, the entire construction world stopped breathing, because nothing like this had ever existed on wheels before. The kind you see poking above skyscrapers can lift around 900 tons on its best day. This machine lifts 4,000 tons. That is more than 4 times the strongest crane in any city you have ever visited. It is the difference between a bicycle and a sports car. And then someone strapped a rocket to the sports car. But here is the part nobody talks about. This crane was not built to show off. It was built for one specific mission, a mission deep in the Gobi Desert, and the thing it had to lift was so tall, so heavy, and so far from any human settlement that no other machine on the planet could reach it. The Gobi is not the soft, golden desert from postcards. It is brutal. Wind tears across it day and night. Temperatures swing from blistering heat to bone-deep cold within hours. There are no cities, no roads built for giants. Just rock, sky, and that endless, screaming wind. And the wind is exactly the point, because China has been quietly building the largest wind farms on Earth out there. Towers taller than most skyscrapers in the world, over 170 meters high. Each one crowned with a metal box called a nacelle that weighs more than 150 tons. Each one carrying 3 blades stretching 108 meters long, longer than a football field, end to end. And every single one of them has to be stacked, piece by piece, into the empty sky. That is not a job for a regular crane. That is not even a job for a great crane. That requires something the world had never seen before. So they built it, and then they had to get it there. 2,000 kilometers across China from Changsha to the northwest. The crane does not travel as one machine. It travels as hundreds of pieces. The convoy that left the factory included the main crane and 28 support vehicles rolling together down the highway. From a distance, it did not look like a construction project. It looked like a slow-moving city. Every single piece of this thing is monstrous on its own. The slewing platform, the round base that lets the crane rotate, weighs 65 tons. That is the weight of 12 adult elephants, and that is just one part. The 2 base sections of the main boom each weigh 66 tons. The rear outriggers weigh 20 tons each. Even the hydraulic cylinders, the metal tubes that push and pull the joints, weigh 32 tons each. By the time all of those pieces arrived in the desert, the real work had not even started. And that was only the beginning, because now they had to assemble the largest crane on Earth from scratch, in the middle of the Gobi, with wind tearing across the site and temperatures dropping fast. 2 support cranes lifted the 65-ton slewing ring into the air. The 4,000-ton crane crawled underneath it. Engineers aligned 2 circular platforms perfectly, while the wind tried to push everything off center. Imagine plugging a massive round plug into a massive socket while both pieces are floating slightly in the air. When the hydraulic pins finally clicked into place, the support cranes let go. Then came the legs. The outriggers extended outward, hiding the crane's tires completely. On top of them, workers laid wide flat pads to spread the weight across the desert floor. Without those pads, the entire machine would sink into the ground, like a stone into water. Then came the boom. 7 sections, each one heavier than a building. In older cranes, workers used to hammer connecting pins in by hand with sledgehammers. This crane uses hydraulic cylinders to lock the pieces together automatically. No bruised hands, no swinging steel, just smooth, precise mechanical clicks echoing across the empty desert. And then came the most dramatic part. The Superlift wings, 2 giant arms that extend out behind the crane like wings on a steel bird. They hold the counterweight, the heavy load on the back that stops the crane from tipping over when it lifts something massive on the front. When those wings unfolded, the entire machine transformed. It stopped looking like a tool. It started looking like something out of a science fiction film. For this job, the counterweight was 260 tons, already a staggering number. But here is the surprise, that was not even close to its full capacity. The crane was barely flexing. With the wings extended and the boom raised to 91 meters, the total reach climbed to 186.4 meters, roughly the height of a 60-story building. And it could still hold hundreds of tons up there without breaking a sweat. Now came the moment everything had been building toward, the lift that changed everything. The wind turbine being installed was a 6.25 megawatt machine. At full power, it produces over 6,000 kilowatt hours of electricity every single hour, enough to light up hundreds of homes from one structure alone, just from wind blowing across the desert. But before any of that electricity could flow, the tower had to rise, and it took 3 cranes working together. A 900-ton crane placed the concrete base ring, an 1,800-ton crane stacked the middle sections, and then the 4,000-ton giant stepped in for the final hardest part, the top. Imagine stacking boxes, each one weighing dozens of tons, each one harder to reach than the last. One mistake and the entire stack collapses. When the tower finally stood at over 170 meters, it was time for the nacelle, the heaviest single lift of the entire operation, over 150 tons. Workers tied guide ropes to all 4 corners before it left the ground. As the crane raised it into the sky, teams on the ground held those ropes tight, fighting the wind, keeping the box from spinning. If it had spun and slammed into the tower at that height, the damage would have been catastrophic inch by inch, hand by hand. They guided it up, and then it locked into place. But the real test was still coming. The blades, 108 meters long, each one longer than an American football field, 3 of them. And they had to come up that mountain. The transport vehicles had to switch to shorter bodies for the tight mountain turns, but shorter bodies meant the 30-ton blade hung off the front like a seesaw, lifting the back wheels off the ground. So engineers added weight. They pushed the total vehicle weight to 160 tons just to keep the wheels on the dirt. 3 blade loaders stood by day and night, ready to catch any shift. Slow, careful, exhausting. And then the first blade arrived at the top, and they could not lift it. The wind. Strong gusts ripping across the ridge. A blade that long becomes a giant sail in the air. Try to lift it in high wind and the cables twist. Control is lost. People die, so they waited. They sat on the ground, they watched the stars come out. They watched them fade again, and just before dawn, the air went still. The lift began immediately, and here's the part that stops you. A machine built to catch wind, installed in the only moment the wind agreed to stop. By the time the sun came up, the first blade was locked in place. The second went up without a problem. And then the third. And just like that, in the middle of nowhere, a 6.25 megawatt turbine stood complete against the desert sky. Now look behind that crane, look across the horizon, hundreds of other turbines, already turning. A forest of white towers stretching as far as your eyes can follow. Every single one of them was once a pile of parts on a truck. Every one of them now keeps the lights on for somebody somewhere. Multiply one turbine by hundreds, then by thousands. That is the scale of what is being built in that empty desert right now. That is the war for the next 100 years of power. And it is being won. One impossible lift at a time. The headline is the 4,000-ton crane. But the real story is the people. Workers who climb to the top of a 186-meter boom by hand to thread cables through pulleys. Like threading a needle at the top of a skyscraper. Teams holding ropes on the ground while 150 tons swung above their heads. Engineers counting stars through a freezing desert night, waiting for the wind to breathe out. This machine did not fall from the sky. It was dreamed up, welded together, and dragged across a continent by human hands. And now it stands out there in the cold, waiting for the next tower. The next blade, the next impossible thing nobody believed could be lifted. The largest crane ever built on wheels. In the emptiest place on Earth, doing the job that decides who powers tomorrow. The future is not coming. It is already turning in the wind.